Okay, I'm here in Taipei and Intel Lunar Lake is launching. It's a new processor. It's aimed at mobile. There's not a desktop counterpart, but Intel is doing a lot of really interesting, innovative things with this. I've never seen Intel behave or act this way. I hope this is a portent of good things to come for Intel. You're not going to be able to buy Lunar Lake for a while, but the reason that Intel is announcing it this early is because the people that are building systems around these chips want people to know what they're building, and they want to be able to show them off the Computex. I'm talking about Lenovo and Dell and HP and other folks that are building mobile computers. Now, if you're a software developer, you actually will be able to get these before Q3. That's when most of the designs around these Lunar Lake CPUs are going to launch into products that you can actually buy. But there is a developer workstation that you can buy today because there's new and different hardware. Like the PC is turning a little bit on a corner, and I think that's super interesting. And that's something that I want to talk about today, because the PC being something different than what it was, it's got to be AI, right? Yeah, it's AI, but it's also a little bit more interesting than that. So let's talk about that and dive in. Overall, I've never seen anything like this from Intel. It feels like probably what Intel should have done when Apple launched their ARM laptops, and light a fire in Intel's belly and really just see them take off. But also, the PC industry is changing forever because AI is apparently here to stay. And that means that the hardware that we have in our machines also has to change a little bit in order to be able to better support AI models so that you can run things locally, and especially mobile computers, because it turns out running, a giant GPU that uses 600 watts of power in a mobile device, not really an option.
So what you will see from Lunar Lake is x86 power like you have never seen it before.
So Lunar Lake is just another CPU, right? Well, I think a picture is worth 1,000 words. So let's take a look at the die shot. You can see here, this is the mobile CPU. Let's get the metal edge around it. That's just a shim to stiffen it up. And then you've got two compute tiles. Yeah, look at that. And then you get two other things. That's your DDR5. But this is all a system on a chip. It's a package. Intel said they're going to save about 205 millimeters of board space with this type of a design. They've also done a bunch of things that are different that we'll talk about in terms of power management. And one of the big things is there's four separate power systems in this. So you have four programmable power delivery things, 4 PMICs, or up to 4 PMICs. You don't have to implement 4 PMICs, but you've got power control over 4 different regions of the chip, which is kind of a first for Intel, kind of, sort of, depending on how you think about it. But power management first is definitely top of the list of things that Intel is worried about for this platform. Oh, and this thing in the corner here, that's just filler. There's not really anything that is going on there. There's just a little piece of silicon there. Nothing going on, don't worry about that. But everything else is the CPU. Now I want to show you the different parts of the CPU, because the parts of the system, the parts that do compute and the parts that are cores, it's not really what you'd think. At least I don't think it's what you'd think. Here's the actual layout. When we're talking P cores, E cores, the NPU, Xe2 Graphics on these 2 compute tiles, which, by the way, are from TSMC. Well, what does that mean that Intel's fabs are busy doing, if not this? We'll talk about that, because they're not idle, I assure you. All right, so in this layout, what's the first thing that you notice when we're talking about the compute cores? You've got the performance cores and the efficiency cores. Those are actually completely new microarchitectures, which we'll talk about, but P cores and E cores is not really a new thing. But this is a generation where I think Intel is probably going to hit this in stride, and we're really going to see what P cores and E cores are capable of, at least if, there's a lot that could go wrong between now and product launch, but at least on paper and at least what I saw in person, it's promising, really promising. But the amount of silicon real estate for the P cores and the E cores relative to everything else, it's really not a significant part of the silicon here. It's interesting, don't you think? Let's take a closer look at our SkyMont E cores. This is on what Intel calls the low power island. It's part of a design that basically means that Intel can shut off the entire chip except for that, or except for that and the media engine, or except for that and the Xe2 Graphics and the media engine, so that the system is operating in a very low power state. And this is a breathtaking improvement over Meteor Lake, in and of that they were demoing laptops side by side that were Meteor Lake and this new Lunar Lake platform, and the difference was like half, like 10 watts, 10 watts playing a Netflix video versus like 4 or 5. Everything else being identical. That's a pretty big savings. Everything is more advanced about these SkyMont E-cores, not just the instructions per clock and other efficiency. One of the things now is they can control the clock frequency in 16.6 megahertz increments. So that is a fine granularity. They've also added acceleration to these cores to be able to do VNNI and other operations that are useful in an AI type context. Now, as for the P cores, that's what they call Lion Cove. We've got brand new performance cores, and they really went completely nuts. Part of the reason for this is to make the design process node agnostic, is what Intel says. That's a nice way of saying we've made it so we can make these P cores, whether we're making them at Intel or we're making them at TSMC. 99% of it doesn't matter. Like, we'll just be able to have it fabricated everywhere. And depending on where and how they have it fabricated and on what process node, they're probably going to get different performance characteristics in terms of power efficiency, in terms of clock speed, stability, all the knobs and tunables. But for the silicon that we saw, TSMC. So as far as I can tell, this is really a total overhaul from top to bottom. Intel promises 14% IPC improvements, and for what they were demoing on the laptops that had the 1-watt screens, it sure seemed like 14%, maybe was even a little conservative for the applications that they were demonstrating. So for the P-core overviews that Intel has, okay, yeah. But again, I gotta go hands-on with this. I gotta get one in my lab. I have to actually do the testing, because it's not as impressive if it's just, juiced at 120 watts or whatever. But it looks like it's got the goods in terms of the design. The potential is there. Next up in our tour of silicon real estate, Intel Xe Graphics 2. So this is a pretty big improvement as well, about 1.5 times faster. In the demo room, they didn't really have a bunch of games running or esports titles or anything like that. And I think that that's probably wise, because there's a lot of time between now and Q3, which gives them a lot of time for driver optimizations. And I'd say it's going to need driver optimizations to really deliver. But this is a brand new graphics microarchitecture. Xe2, probably going to see that in Battle Mage, probably, kind of, sort of. Can't comment on future products, but yeah, it looks like a totally new graphics microarchitecture. They even threw in a little bit of ray tracing. There's ray tracing and an iGPU, like ray tracing acceleration. Yeah, they weren't bashful about talking about that either. I did get to see a graphics related demo that was combining AI and graphics that used the dev platform. The power brick for the dev platform was 120 watts, but the thing also wasn't emitting a lot of heat. So it might not have actually been using 120 watts. Not really sure what to make of that. I'm sure that mobile parts are not going to be configured for that. Like, that's not a thing. But the demo was running DaVinci Resolve, and it was doing AI to find, an outline of someone's face to help with compositing for a special effect. Okay, that's cool. But it was running at a pretty impressive 6 FPS for 5K source material. So that's pretty good. The slides look interesting, and it looks like that everything is geared up to be usable in DirectML as well, meaning that we still have CPU and GPU operations that can run in an AI context. And Intel in their messaging said that for things that are performance oriented for AI, it's probably still going to run on the GPU. And this looks like you do have a fair bit more GPU horsepower. But again, that's something we'll have to test, keep an eye on a little closer to launch. But that sort of bleeds into our conversations about the NPU, because the neural processing unit shows up in the Windows driver stack as WDDM. It's a very similar driver architecture. UMA hooks and all that are exactly the same between the GPU and the NPU. And the NPU also has its own direct memory access controller, its own DMA controller basically, and also like 8 megabytes of SRAM. And this is an improvement over Meteor Lake, which I think had 2 NPUs, but there's 6 on this platform, or at leat on the units that we took a look at. And it looks like the performance per unit is a little bit less, but you've got 6 of them, and that can consume a lot more power. So in terms of efficiency, they're actually 2.9 times more efficient. So to do the same job on Meteor Lake is going to be way more power displacement, because with 6 of them running at a different power envelope, it's 2.9 times as efficient. And you also get it done in about 100 milliseconds as opposed to 350 milliseconds. So it's interesting because they consume a little bit more power per unit, but they're so much faster, they get the work done so much quicker, you have a pretty strong net power savings. Now, the RAG demo, or retrieval augmented generation, is basically you're running a large language model, but you feed it a bunch of documents, you give it context, and then you can ask questions about the documents that you fed it. And being able to run this on a Lunar Lake system, which is theoretically, I think, for the volume mass market thin and light notebooks, and being able to see it run as well as it did, very impressive. Very good use of the NPU, the CPU, and the GPU for doing this thing here. Whisper AI was used for voice capture, and then the thing ran on the NPU to actually do the retrieval augmented generation. So pretty neat little demo. I think this should be able to run Copilot Plus no problem once the software plumbing for that is worked out. It's 40 to 45 TOPS on the platform, depending on which SKU you get, so not bad. The other thing Intel wanted to talk about was connectivity. Thunderbolt and their new software, Thunderbolt Share, and the software that you get right now, which is to do with file sharing and mobile access. And this was the slide where I was noticing things that I know are not exactly, that may be slightly misleading. So this platform has Thunderbolt 4, not Thunderbolt 5. Okay, if this is a mainstream platform and not an enthusiast platform, or not the highest performance platform, okay, maybe it makes sense that Thunderbolt 5 is not going to hit your power targets, it's not going to be able to do thin and light. Maybe you could use the PCIe Gen 5. There's 4 PCIe Gen 5 lanes and there's 4 PCIe Gen 4 lanes off of the system on chip. That's pretty much it for the PCIe connectivity that they talked about. So I think it's just 2 groups of 4 lanes. And they also mentioned DisplayPort 2.1, but DisplayPort 2.1 has a much higher signaling rate. And when I asked about that, they didn't seem to think that the interface would actually have a faster signaling rate, given that Thunderbolt 4 is relegated to about 10 gigabit. And at DisplayPort 2.1, the full fat implementation is 77 gigabit. So I think what they mean when they say DisplayPort 2.1 is probably just display stream compression. It's DisplayPort 1.4 with display stream compression. They also said on the slide, it's like, oh, Thunderbolt 4 has gotten 4 times faster in 5 years. No, pretty much a year to 18 months after Thunderbolt 3 was introduced. Like when Thunderbolt 3 was first introduced, it was 20 gigabit mandatory, but you could do optionally 40 gigabit, 2 lanes to 4 lanes. There's 4 lanes on the cable for data. But in the early days of Thunderbolt 3, you only had to implement 2 lanes. Some of the last Intel MacBooks, well, the generation before last Intel MacBooks, 2 of the Thunderbolt ports were 2 lanes and the other 2 were 4 lanes, but you couldn't use them all at once. Big giant mess. Maybe that's what they're talking about, but pretty much everybody has been 4 lanes of Thunderbolt 3 since time immemorial, at least a year or 2 before Thunderbolt 4 was even a thing. So we've been stuck on Thunderbolt 3/4, 40 gigabit maximum. And 40 gigabit's misleading because if you use the connection between machines, you connect 2 Thunderbolt machines, you're relegated to 20 gigabit. If you followed other content on this channel, you know that I've suggested that as hey, if you're running a Linux server and it has a Thunderbolt interface, you need it to talk to another Linux server, you can do that, but you're going to be limited to about 20 gigabit. Well, you're still going to be limited to about 20 gigabit. And that's what Intel's Thunderbolt Share program is. It's a piece of software that runs on top of Thunderbolt networking. And so really, this is something that should have been part of the operating system and something that Intel offered since forever ago. But I think it actually is a good sign that the philosophy of the situation is changing. Somebody inside Intel's looking at this and saying, yes, we need to actually build a good end user experience because Microsoft's asleep at the helm. They're not going to do that. We could have done this forever ago. And Apple, for their part, they have done Thunderbolt networking since Thunderbolt 1. And they provided a lot of really interesting software on that Thunderbolt interface to be able to do things. I would really like to see this platform be able to support, 2 5K displays at 120 hertz each. And you could probably do that with 2 connections on the Thunderbolt side. They did improve the PCIe connectivity for the controller. You're still not going to be able to saturate 2 40 gig ports, it sounds like. I'll do that test as soon as I've got a Lunar Lake system. But it does sound like that you've got an extra lane of PCIe bandwidth, or that you've got 4 Gen 4 lanes to the controller, which would let you saturate 2 out of your maximum 3 Thunderbolt interfaces. They also said it would definitely support 3 4K 60 displays, but I'm having trouble reconciling that. It's probably 2 4K 60 or 3 4K 30. But again, I'll have to test that, we'll see. But overall, don't read too much into that. Those are just some little things that I'm worried about. If Intel hits their power targets and their functionality, they are coming out swinging in terms of power efficiency and features of the platform. If this is the volume production, mainstream, affordable laptop, the fact that Intel's doing all the work in the system on chip, there is Wi-Fi 7, there is a gigabit Ethernet PHY, like not 2.5, just the one. I guess they figure most people are going to have Wi-Fi 7, which is much higher bandwidth potentially than wired Ethernet. Okay, that makes sense. A lot of clever stuff there with the Wi-Fi 7, including dynamic control of the DDR5 memory controller to minimize RF interference on the Wi-Fi side of things, which yes, that is actually a problem that you run into, is the RF frequencies emitted by your high clock speed circuits inside the laptop. It's like, oh, we need to deal with that. No, the system on chip deals with all of that, which hopefully simplifies life for people that want to build systems around this chip. And I think that's some of the success that AMD has enjoyed with their embedded CPUs, is that with AMD CPUs, they're doing a lot of that kind of work for integrators. It doesn't necessarily give integrators maximum flexibility, but it does mean that maybe there's a lower BOM cost, or maybe the motherboards are less complicated, or maybe they can shrink things down. The Lunar Lake laptop boards that they had in demonstration at the event were definitely very tiny, which maybe makes things easier for people that are building systems around them. So I think that as long as Intel hits their targets, they've potentially got a very powerful mainstream platform here, which might enable them to do this kind of thing, to have this kind of ambition and fire elsewhere in the product stack. I would love to see something with this much fire and enthusiasm, but taken up to the nines for something that's a unified memory architecture, 96 gigabyte or 128 gigabyte laptop. I mean, that is going to bring x86 back in terms of the performance crown and everything else. I mean, people are buying $10,000 Apple laptops that have a bajillion gigs of memory to do all of their AI stuff on, and not well, because Apple is so asleep at the helm that the next generation of MacBook that has some of the AI stuff is going to be a marginal change in how Apple does their architecture, but a dramatic improvement in the end user experience for running large language models and everything else. And so I think that we can have that kind of an aha moment on x86 on PC, before ARM takes over the world. At the same time, it seems like Microsoft is really preoccupied with ARM and Copilot Plus and the AI features, where we've got some of these new parts that are entering the market that have a lot of AI horsepower. And the deal with the NPU in the new CPUs is that you can run a lot of these AI tasks in the background at very low power. The GPU is still going to be faster for a lot of AI tasks than the NPU, but the NPU is going to use a fraction of the power and be running in the background and not busy the CPU or the GPU with other stuff that would interfere with user interactive processes. Intel's leaning pretty hard into that. Most of the silicon real estate here is not concerned with the actual CPU cores. It's concerned with everything else. And everything else is part of what's making sure that you're going to have a good laptop experience. So it's really interesting, I think, and a little bit of a departure for Intel, but they really are leaning into the, no, we must build this to build the best possible user experience, which I think is a very interesting change in direction. Pat Gelsinger and stuff, I don't know. Time will tell. It's going to be interesting. So overall, right now, I'm cautiously optimistic about Lunar Lake. We'll see. Got to get hands-on. We'll see. Should be good. Oh, and I mentioned TSMC. TSMC is responsible for the compute tiles here. So what does that mean Intel 3 is busy doing? Well, I don't know, but I've got another video coming out on the Intel Xeon 6. You should probably watch that. The answers might be in there. Possibly. Maybe. Possibly. It's not that the Intel fabs are idle. Let me tell you, it's not that at all. But I would also guess that the new Xeons are built with a similar fire and passion, which is going to make things really interesting. And also, Intel is doing exactly what their customers are asking, which, is that legit, or is that like monkey's paw curls kind of thing? I don't know. We're going to find out. I'm Wendell, Level 1. I'm signing out. You can find me in the Level 1 forums if you have questions, or if I've left anything out, or if anything is not exactly all there. But we'll see. All right. I'm signing out, and I'll see you there.